Today, we're going to tackle one of the biggest, most mind-bending ideas in all of science. It's an idea that basically pulls the rug out from under everything we think we know about the universe. I mean, think about it. Everything you do, every single moment of your life, it all plays out on the stage of space and time. But what if that stage isn't the bedrock of reality? What if space and time themselves are just an illusion? What if they emerge from something much deeper, much stranger? Okay, let's get into it. You see, for about a century now, physics has had this massive split personality. On one side, you've got Einstein's general relativity. It gives us this beautiful picture of a smooth, flowing, continuous space-time. But on the other side, you have quantum mechanics, the bizarre world of the super small, which is all chunky, pixelated, and based on probability. These two theories just do not play well together. And finding a way to unite them, that's the holy grail of modern physics. The answer might just be that our smooth reality is actually built from all those tiny quantum pixels.
So, if we're going to build a universe from scratch, we need the right building blocks. And for this story, our main ingredient is something Einstein famously called spooky action at a distance.
Yeah, that spooky action is what we now call quantum entanglement. And you can just think of it as the ultimate connection. It's like a quantum superglue. When two particles are entangled, they're linked in this incredibly deep way. What happens to one instantly affects the other, even if they're on opposite sides of the universe. Now, this isn't just some weird party trick. A lot of physicists now believe this is the fundamental stuff that literally knits reality together.
Okay, so if entanglement is our thread, how in the world do we start weaving it into the actual fabric of space? Well, a pretty new framework gives us the kind of blueprint for how to do it.
It's called CRET, which stands for Constraint-Resonance Emergence Theory. It's a bit of a mouthful, I know, but the idea is powerful. It's a step-by-step guide for how our normal, classical reality can emerge from these deeper quantum layers. It literally builds our world from the ground up. And what's really cool here is how CRIT organizes reality into 3 distinct layers. It all starts with these fundamental quantum pixels. Then it uses entanglement to stitch them together into a kind of web. And from that web, our classical spacetime emerges, with all the rules we know, like gravity. Let's break that down a little more simply. Right, here it is in 3 simple steps. First, you start with an unimaginable number of tiny quantum pixels. Think of them as qubits. Step 2, you connect them through this vast, growing web of entanglement. And then step 3, once that web gets dense enough and complicated enough, poof, a stable, large-scale shape emerges. And that shape is what you and I call classical spacetime. This process of building upwards is called upward amplification. The best analogy, really, is weaving a piece of cloth. At first, you just have a bunch of loose, separate threads, but as you weave more and more of them together, they hit this critical point, a threshold, and suddenly they're not just individual threads anymore, they're a single, smooth, continuous sheet of fabric. It's the same idea here. Once entanglement hits a certain critical density, a smooth geometry, space, just emerges from that pixelated quantum mess. But, and this is the really wild part, this isn't a one-way street. The space-time that gets created doesn't just sit there passively. Nope, it actually pushes back and influences the very quantum web that it came from. This is the other half of the equation, downward selection. The big macro shape of space-time starts imposing its own rules, things like temperature and entropy, back down onto its own quantum foundation. It's like a thermostat for reality, selecting which entanglement patterns are stable enough to exist and which ones aren't. It creates a perfect feedback loop. Now here's the crucial insight. In this model, gravity isn't a fundamental force at all. It's the result of this feedback loop finding a perfect, stable balance. Our universe, the one with gravity, can only exist because this upward building and this downward regulating hit a self-sustaining sweet spot. That stability, that resonance, that is what we experience as gravity. And this quote just nails it perfectly. What we call the curvature of space-time, the thing that we feel as gravity, it's really just the stable, self-maintaining shape of this constant two-way conversation between the quantum world and the classical world. Okay, so we've woven the fabric of space. That's a huge deal. But what about time? Where does that relentless, forward-moving arrow of time come from? So if space is just the static pattern of how all of these quantum bits are connected, then what on earth is time? Well, it turns out the answer uses the exact same ingredient we've been talking about, entanglement. Okay, this slide right here, this is the whole ballgame.
If space emerges from the pattern of entanglement, how things are connected right now, then time emerges from the growth of entanglement. Time is simply the process of new quantum connections constantly being formed. It's not a river we're floating down. It's a process that's happening everywhere, all at once. Time is creation.
Now, for this process to have a direction, for time to have an arrow that only points forward, you need two key things. First, you need that constant ongoing growth of entanglement, but you also need a very special starting point. The universe had to begin in a state of really low entanglement, what physicists call a low entropy past hypothesis. This special beginning gives the growth somewhere to go, and that's what kicks the whole story into forward motion. So why can't we go backward in time? The short answer is a process called decoherence. As new quantum connections are constantly forming, information about what just happened gets scrambled and spread out across this ever-growing web. It's not that the information is destroyed, but for anyone like us inside the universe, piecing it all back together becomes practically impossible. The past gets locked in, and that's why the arrow of time seems to fly in only one direction.
All right, so let's put all the pieces together. This Krebs theory gives us a radical new map of reality, one built entirely from quantum information. And you know the best part? This isn't just a cool story, it's actual science.
So here's the whole idea in a nutshell. 1, space is the pattern of connections. 2, time is the growth of those connections. And 3, gravity is the stable feedback loop that holds the whole system together. I mean, it's such an elegant and powerful way to see how our familiar world can arise from this bizarre quantum foundation.
And I really want to hammer this point home, because unlike a lot of far-out ideas in physics, this isn't just a philosophical daydream. CRT makes specific, concrete predictions that we can actually test in experiments. It gives us a way to try and prove it wrong. For instance, the theory predicts that gravity itself can create and transmit entanglement. And believe it or not, scientists are running experiments to test that right now. It also predicts that on the scale of entire galaxies, gravity should behave a little differently, and that change could explain why galaxies spin the way they do without us having to invent something like dark matter. These are real, high-stakes tests that could either support or completely break this entire idea. I just think this is a fantastic way to sum it all up. Gravity isn't some mysterious force pulling us down. It's a large-scale rule, a constraint that just crystallizes into existence once that underlying quantum web becomes complex enough to support it. It's an emergent property of the universe. And that leaves us with one final, pretty profound thought. For pretty much all of human history, we've thought of space and time as this fixed, absolute stage where the drama of reality plays out. But if that stage itself is just a collective illusion, an emergent effect of a deeper quantum reality, you have to wonder, what else about our world is too?